I want to spend a few minutes to discuss what really happened when you insert a proxy in the middle of your architecture or your backend. And this video is going to be really technical, so there's a lot of details of what exactly happening behind the scenes. And that's, I guess, if you're subscribed, you know the nature of my videos. They always go technical. We try to peel the onion of what is underneath what we're using. A lot of people don't agree with this approach. People like to use black boxes. Hey, if it works, I don't want to know how it works. But if we really want to take pride of our craft, especially engineering, I try to understand everything that I interact with, at least if I have interest in it. Let's jump into it. Welcome to the Backend Engineering Show with your host, Hussein, Nasser. And before we insert a proxy and understand what a proxy does to your networking, we really need to understand what really happens when you just visit a website as in its core. And assuming there is no other things that your ISP, shady business that your ISP does, like it's inserting its own proxies and whatnot, you're directly connected to the website. So let's say you want to go to google.com and you're behind a LAN. What you do is you do a DNS, give me the IP address of google.com, you get an IP address, and this IP address is definitely outside your subnet, right? Subnetwork. As a result, you go into this how you discover and how you route your IP address, how you route your packets in order to go all the way to that destination. And that's the magic of IP routing. I talked about it many times on this channel. But in a nutshell, what you want to establish is a TCP connection directly between you as a client and the destination IP address as a server. So you would send a SYN synchronization request, which is a TCP packet, and that synchronization request will be eventually routed throughout the internet from one network to another until it reaches the IP address of Google, and that Google will say, okay, I accept your connection request. I'm going to send a SYN-ACK, and it will follow the same thing. It will be routed through the internet to your public IP address. You might say, Hussein, you just said that I am behind LAN. I don't have a public IP address. Well, that's the magic of NATing, and that your router does. Your router is the public IP address, and it represents you, right, in the internet effectively. And then you establish a TCP connection. And then the next thing, once we have a TCP connection, it's a web request, right? So we're sending a GET request. How do we send a GET request? That's an HTTP method. And now we're playing in layer 7 land in the OSI model. We have a connection, and now we send the first packet, says get / HTTP 1.1 or HTTP 2, depends what the protocol negotiation happened. And even before that, there was a TLS, which is a secure connection happening. All of this is just additional stuff that happens. But the most important thing is the connection, really. So the GET request goes directly to the server through the same ID, same path, effectively. It will be routed. This GET / will be packaged into TCP segments, which will be IP packets, and then same thing, goes to the internet, goes eventually to the Google server. And then Google will parse that GET request from the TCP segment. It could be one TCP segment or more, right? And then it will assemble that into one thing and pass it to the layer 7 and says, oh, it's a GET request. Because at that level, if you're looking at packets, you don't understand what this thing is. There's encryption involved, there's stuff like that. You have to decrypt it, you have to assemble it, and then deliver it to the application running on port 80 or 443 if you're secure, and then you respond, right? You receive the request, you acknowledge it, and then you stop processing it. That's how things work without a proxy. So now, did we explain what a proxy is? I talked about it many times. A proxy is a thing that makes a request on your behalf, but this is a very vague statement. We want to unpack that from a technical level. You install a proxy usually on your machine, and there are many types of proxy. So in this particular case, you're making a web request, HTTP request, so you need an HTTP proxy, a proxy that understands how to make HTTP request, right? Because that's the thing, because it's gonna make the request on your behalf. It's gonna take your place. Google will see the proxy, it will not see you, okay? And we're gonna explain what do we mean by see here, right? Because a lot of people now, networking people, say, nah, oh wait, we'll come to that. So that's what our proxy is. When you go to your networking settings and you say, hey, my HTTP proxy is actually this IP address. It's a server running on the internet. It also happened to be the same machine as well. You can put the HTTP proxy in your same machine. That's how Fiddler and man-in-the-middle proxy works, by the way. But it's essentially a server listening on a port, right? And then you're making the request to it, right? It has when you configure your proxy, you specify the port and you specify its host name or the IP address. So now, your machine all of a sudden now understands that you have a proxy set up, and the equation changes. Let's go back to our example. I'm curling Google, or I'm visiting google.com. When you do that, you ask your operating system to, hey, I am going to google.com, and it goes through a set of APIs that says, okay, I know I'm gonna do a DNS, I'm gonna get the IP address of Google, but you're using a proxy, so we are not establishing a TCP connection with Google anymore. We're not? No, we're not. You're gonna establish a TCP connection with a proxy. So now all of a sudden, okay, what's my proxy? You ask the question, okay, this is the IP address of my proxy, and if there's a host name, you have to do a DNS to get the IP address of the proxy. And once you do that, you establish a TCP connection with the proxy, and this is identical. Do a SYN, travel the internet, route it, find the proxy accepts the TCP connection. Now you have a connection between you and the proxy. And the next thing you do, optionally, you might have an HTTPS proxy. Kind of complicate things, but it's the same concept. You're going to do a TLS with your proxy. If that's the case, then it's a TLS termination proxy. Be very careful of those, right? A lot of people I see use proxies instead of VPNs. You need to be careful what kind of proxies are using, because it decrypts your traffic. VPN does not decrypt your traffic, right? But that's another topic. So now we have the TCP connection, and now the next thing we do is the HTTP client, right? I'm gonna use unsecure things for simplicity, because with security you have to use another HTTP method that we're going to talk about. So now the next thing after establishing TCP connection with a proxy, you send the GET request to the proxy, right? Asking it, say, I want to go to google.com. Right, so Hussein, how does the proxy know that you're going to google.com? Well, for the longest time, we didn't have the knowledge of google.com in the GET request, if you think about it, right? When I send a GET request, hey, I know I'm connected to google.com. I'm not going to say, hey, I want to google.com. So future HTTP version added a header called the host header in the HTTP request. And now when you send a GET request, you also had said the host header, and most of you might have seen it all along. Yeah, this didn't exist in HTTP 1.0 or 0.09, right? They added that because they want to proxy. Otherwise, you have no knowledge. Remember, HTTP is a stateless. We need to tell it with every time you need to deliver all the necessary information about the state. Yeah, you need to transfer the state. That's why REST is state transfer, right? You have to transfer the state with every request. And that's the state now is, hey, I'm going to google.com. So the proxy looks at the host header. That's how it knows, oh, you want to go to google.com. In this case, the proxy finds google.com, does a DNS, and establishes, find the IP address, establishes a TCP connection between itself and google.com. And now we have a TCP connection between the proxy and the google.com, right? And up until here, Google have no idea who we are as an original client. It just knows that a proxy connected to it. And the next step, the proxy needs to take the GET request that you sent it. And now all of a sudden, now you're blocked. The whole thing is synchronous here, right? You're blocked and waiting for the response. And the proxy is now sending the GET request on your behalf to google.com, taking that GET request and sending it across. Now, most proxies actually delivers the originating client in the header itself. Why? Because, hey, it have full reign. It is sending the request again, so it can modify the request, it can change it, it can add, it can subtract, it can falsify, it can do anything, because it's basically seeing everything, right? So if we're doing that way, then it can rewrite and add the X forwarded to, I think that's what X forwarded by, all these headers that says, okay, this is the original client. Fascinating stuff. So now the Google can actually know the originating client or any other proxy. And Envoy, the proxy I talked about, actually sometimes you have to add this header so that we know the original client in order to, I don't know, like block it, for example. Say, you're really sorry, you cannot really access that content. You are from this region. No. All right. Sometimes you have to forward, so that's why some proxies add that header. So now this is what happens. The Google will receive the request, right? Same exact thing, and then it will parse it, do all that stuff, respond back to the proxy, and then goes its merry way, right? Get the response. Now all the proxy does is now it will unblock the client. Hey, you sent me this request, remember? All of a sudden now I'm gonna respond back to you. You might say, Hussein, what if I'm sending 7 requests? Are we opening different TCP connection with every request? No, that's where the elegance of design of the proxies come in. It's like, nah, we're not gonna open a connection for every request. That's dumb, right? That's so dumb. We don't do that. Otherwise, we're gonna waste resources. Imagine we have a lot of clients, everyone making 100 requests. We're dead. The proxy is dead. So that's why the proxy is smart enough to know that, okay, both these guys are going to Google. I can technically pull these connections. It becomes slightly dangerous if you're authenticated, right? You really need to make sure that these the connections are really dedicated, right? You can share in certain instances, not all of them, but some connections that are shared can cause one response to go to another wrong client. Sometimes all sorts of bugs that happen with HTTP smuggling and stuff like that. But that's the idea. We share the connection. Like if the next time you made a request to Google, we kind of link this connection to you as a client, and then we're gonna future request goes to always this connection. So now what happened if the proxy is an HTTPS proxy? It's a secure server, right? And the destination is also secure. This is where HTTP tunneling comes into the picture, because now the proxy can terminate TLS, but it's a little bit dangerous. So the proxy, what the proxy does is it does something called HTTP tunneling. It tunnels everything that you sent all the way to the destination, right? So here's what happened. The client will establish a TCP connection with the proxy. The proxy will see, okay, that's just me and you, right? There's nothing, I don't know anything about where you want to go. So the next thing is the immediate request, because the client knows that it's an HTTPS proxy, is a connect request. I don't know if you heard of this method, connect method. I talked about it, I think. Check it out in the video here. HTTP tunneling, connect method, details, and what's gonna replace this method, all this stuff. There's so much history in this. Now, obviously, the client also complete the TLS session with the proxy, because it's a secure session between itself and the proxy. And now the next thing sends the connect request and says, hey, connect me to google.com. So the proxy, all what it does is, okay, you want to go to google.com? Sure, I'm gonna establish a new TCP connection between myself and google.com. So still, Google doesn't know that we're connecting from the client. It knows that, hey, just establish a TCP connection. Just do that. And the connect method has a special logic that says, okay, link anything in the future after this connect method, anything that I send you, please just deliver it to the other party and the connection that you created on my behalf. So the next request is, let's say it's a GET request. Hey, GET slash. It's technically not a GET request. It's the next request is a TLS handshake, right? So the TLS hello will be delivered just another TCP packet going to the proxy, again encrypted with the proxy certificates and the keys. And the TLS handshake to the proxy is just, hey, I am supposed to blindly just tunnel things through this connection. So it will literally just change the IP address from itself, from the client to the itself, and then send the TLS hello. That Google will reply back with the information, TLS server hello, and then the proxy will receive it. It says, oh yeah, oh you came in from this connection, that's a tunnel. Blindly send it back to the client and just change the IP address, right? So it's still two TCP connections, but it's almost like one. It's like almost like a tunnel. We just flip the IP addresses here. So now it is true end-to-end between the client and Google. Google still doesn't know it's talking to the client, right? And the proxy doesn't understand the communication between the client and Google anymore. It just blindly forwards it, right? And as a result, you have end-to-end connection. You have one symmetric key that the client knows and only Google knows. So now the next GET request is actually encrypted. It's a jumbled mess that the proxy will receive as a jumbled byte mess, and the proxy is responsible. Hey, it came from this client, from this source port. That is effectively linked to this tunnel. So I'm gonna tunnel you. It's like a smuggling, right? Hey, go to this TCP connection. It will smuggle the data. Just send it, and it will be blind. That's it. It will be completely blind. So the proxy in this particular configuration doesn't see anything. You might say, Hussein, what if, just what if the proxy looked at the TLS client hello that is sent to Google and decided to play sneaky, to play a fox? Hey, I'm gonna respond to you on behalf of Google. It can create a wild card certificate that is fake. Obviously it can never be signed by Google, but hey, it's signed by me. It's a self-signed certificate that claims to be google.com. Anyone can do that. You can do it right now. A google.com certificate, but it's self-signed, because no certificate authority will sign you a google.com certificate, obviously, right? And then I'm going to respond back to this self-signed certificate claiming to be google.com. That's how man-in-the-middle works. That's exactly how man-in-the-middle proxy works. That is exactly how Fiddler works. That is exactly how Charlie works. You have, as a client, you have to install that certificate in your machine so you can trust the proxy. We do it all the time when we want to capture backend requests, right? Well, front-end requests, but anything that goes from the front end to the backend. I want to see what the mobile phone is sending, what SMS I'm sending. You can do it right now. It's so simple. But the cost is you have to install this certificate. It's dangerous. It's very, very dangerous stuff. You have to know what you're doing. Because if you're doing a debug process, and man-in-the-middle proxy is smart, they generate this unique thing, right? So this, if you install this certificate, right, from man-in-the-middle proxy, and someone else has man-in-the-middle proxy and try to intercept that, it will still reject it because it's unique. These certificates are unique to your machine, so nothing to worry about when it comes to debugging. But I'm just saying that using a proxy in general, right, to hide your identity, for example, yeah, if it's a HTTP tunneled, sure. But if they ask you, hey, by the way, in order to use our proxy, please install this certificate so that we can successfully serve you. No, never install any certificate at all, because that's gonna decrypt the traffic for you. Unless obviously it's your company, for example, and they have the administration and they install it for you. You can't say anything about that because your company can necessarily, they want to see what you're doing, right? All right, guys, so that was a long video actually about proxies and how proxy works, the anatomy of proxy this. Thank you so much. I'm gonna see you on the next one. You guys stay awesome. All this. ありがとうございます。